I'm going to turn it over to Matt.
Thanks, Trent. Okay, so you're going to have to bear with me because I am using a laptop that's not my own, and if there's something untoward on here, it's his fault. Okay, so we're going to be talking about Scala.js, and how many of you have heard of Scala.js before? That's good. How many of you have heard of Scala before? How many of you just refuse to raise your hand for anything? Okay, I see. All right, so how many of you use Scala at work? That's a very low number. How many of you use any functional programming language whatsoever at work? What?
What if you write code functionally?
If you're using Java, it doesn't count. If you're using JavaScript, it almost counts.
Okay, we'll go with that.
What other languages?
We use the listserv.
Do what?
We use the listserv for backend service.
Okay. What when?
Haskell.
Ooh, fun. Okay, so we're going to be using Scala. We're going to be using Scala.js, and for anybody that's not familiar with the concept of what Scala.js is, it's Scala, but instead of running on the Java runtime environment, it runs as JavaScript in the browser. So giving you the ability to write your beautiful, wonderful, compiled, type-safe Scala code, and it gets compiled down to JavaScript that then runs in the browser. So awesome. We are going to be using SBT. It's a Scala build tool. And if you're not familiar with that, we're going to be, I don't have IntelliJ on here, so I'm going to be struggling in Vim and writing everything by hand. So we'll see how well this works. So you can mock and ridicule, I don't mind. Okay, so, oh wait, now how many of you actually have done anything at all with Scala.js? Nice. Okay, cool. Let's move on. All right, the browser, I'll look back. So back in the olden days, back whenever web pages were still early development and most content was static, almost everything dynamic being done was done on the server. So you'd make calls down to the server, you'd have form push requests that go down to the server and respond back with a response, and it's the simple submit response for every page that happens. Now, we've moved a little bit beyond that now to the idea of more thick clients. Those were called thin clients because they did very little on the client. All the heavy lifting was done on the server. So that worked well for the most part, but it gave us a big limitation as far as what we were able to do. Things like, things that you see today, like auto-completion on forms and things like that, just couldn't be done in the thin client model well. I mean, several years ago, they would still do things like AJAX request down to the server and respond back. So most of the heavy lifting was still being done by the server for everything, but it would respond pretty quickly on the client. But that was still thin client for the most part. But now we've got the power of JavaScript and a lot of functionality available to us in the browser. So we want to take advantage of that if we can. And that's what JavaScript lets us do. And my fourth point on here says JavaScript, the monopolistic language, because as of today, for the most part, JavaScript is the only way to write code in the browser. We have WebAssembly now, but that's not widely supported yet, and when it does, JavaScript may well die a painful death, but that's still a ways off. So for the moment, at least, we're stuck in JavaScript. And so you've got dozens of languages out there that compile down to JavaScript so that they can use their language in the browser. And that's essentially what Scala.js does for us. And so for a long time we had ActionScript and Flash, but we won't drudge up those memories. GWT, have any of you guys used GWT before? Painful, wasn't it? Primary problem was error handling, right? Anytime something would go wrong, you'd see this weird stack trace in the browser console and just horrible things. You'd have no idea how to get back to it, how to deal with it, just horrendous. And so a lot of people compare Scala.js to GWT, but it's not a fair comparison. Scala.js is what GWT should have been, but wasn't. It has proper representation of error handling. You can actually throw and catch exceptions in Scala.js. For the most part, you can deal with error handling the same way that you deal with error handling in the JRE, which is very, very nice. Okay, so now we've got things like TypeScript, which is probably the best solution for working with JavaScript. It adds some type safety concepts into the browser, which is nice. And then we've got Dart, Kotlin, and then all sorts of other stuff. And as I mentioned before, WebAssembly, which if you're not familiar with WebAssembly, it's very exciting. It is actually, I don't know what that was. Okay, so WebAssembly it compiles your code down, and let me emphasize that word, compiles your code down so that you can actually run compiled code in the browser, not interpreted on the fly the same way. It's more like bytecode for the most part in the browser, but it's not Java, it's not the JRE, it's WebAssembly, which is a cooperative effort between Mozilla, Microsoft, and Google, and a bunch of other people, Adobe, and all these people. So it's got a lot of traction, and it's probably the way things are going to be going. You'll be hearing a lot more about WebAssembly as it really catches on more, but how many people have actually heard of WebAssembly before? And me saying it a minute ago doesn't count. Okay, all right, so I really like this image. I thought it was funny. Okay, so benefits of Scala.js is we have complete JavaScript integration, which we'll get into more details about that in a minute, but we have the ability to run our Scala code as JavaScript, but one of the first concerns that I'm sure if you're a programmer enters your mind is, well, what about existing JavaScript libraries? What about these specific things that work differently between the way JavaScript deals with objects and the way that Scala deals with them? And all that is very, very well handled. But so with regard to JavaScript libraries that already exist, you have what are called facades that add a type-safe wrapper around the JavaScript code. Basically, you can think of it as like a stub representation of this is what it's actually doing in that dynamic mess over here. Here's a type-safe representation of that so that we can interact with it. And another great benefit of Scala.js is whenever it compiles down in performance comparisons, very often the compiled Scala.js code is actually faster than what you might write just by hand in JavaScript, which is pretty awesome when you think about it. And it's because they do a lot of optimizations and things that you wouldn't otherwise do. It's the same reason that Java is often faster than C, because that seems like a mind-blowing concept, but because of the just-in-time compiler, because of the runtime environment, all the optimizations that it can do can beat your average C code. Now, just like in C code, you can write faster JavaScript code than you could write Scala.js, but it's a lot more effort and a lot more pain to do so. So in general, the benefit here is just you can write normal, clean code and everything works great. Okay, so one of the biggest complaints or concerns I hear whenever I mention using Scala.js is, well, we don't want to teach our designers Scala to be able to make them be able to interact with the content. And I totally agree with that. But the idea here is that we're changing, whenever we deal with Scala.js in the browser, it's blurring the lines. So instead of having your designers working on the front end and your developers working on the back end, you have your designers creating HTML templates for the look and feel, and then you have your developers working on the server and the client hooking up and interacting with those templates. And then, yes, it does make a little bit more work for the developers, but it's actually cleaner and much more effective than doing it the other way around, because The designers can be completely hands-off. Your designers will love you because they don't have to inject any JavaScript or other mess or interactivity, and you're not muddying their waters of their templates with your crap, which is what they think of your code. So it keeps everything very pure. And so it allows you as the developer to not mess with the garbage of design. You just hook up to existing designs, and you can interact with things just like you would with normal JavaScript using lookups by ID, by class name, by tag name, whatever you would otherwise do. And then you just interact with it, you inject content, you change content, you generate your own content, whatever you need to do, you can do so. Okay, so I've gone into a lot of this already, but the big question is, why would you want to do this? Why would you want to use Scala.js over JavaScript? And I think there's a lot of reasons. If you're not a big-time lover of Scala, and you have this weird concept that JavaScript is fun to use or something just wrong, then this may be more difficult to understand. But modularity is a big one. Modularity in JavaScript is painful. Nobody I have ever talked to disagrees with that concept. Does anybody want to disagree with that concept? Okay, good. I was worried. Okay, so you have better modularity. You have access to most of the Java library, which is really awesome because Scala.js, they have to compile your code that was written, for the most part, for the JRE. They have to compile it to JavaScript. And so they had to create ports of much of not only Scala's library, but also Java's library, because as a Scala developer, you very often access Java classes, like Java util_date, or the system.currentTime, or any number of things, but they created ports of those for JavaScript so that whenever you compile your code down, it still just works. Now, I said most of, there's still a lot of things that are missing. For example, java.io.file, not going to be accessible in the browser. And then you have, there's certain things that are different, like regular expressions. It uses the browser's implementation instead of the Java implementation, so things can get kind of quirky there. Okay, so let's actually look at some code here. And we're going to create a project. Actually, we'll create a project now. This is tiny. Let's make it bigger. Oh, yeah. That's too easy. How's that? That big enough? All right, we're going to create hello Scala.js. We're going to create our first project. So the first thing we need, if you're dealing with SBT, which we are going to, is we need a build.sbt file for our project. That's actually the minimum for a SBT project. If you guys are familiar with Maven, you can really appreciate the fact that this is all that's required. Done, we have a project. That's really all that's required for, actually that even is not required, you can technically build without it. But Maven users, how many lines of code does it usually take to create a project? You don't know, you copy and paste, don't you? Yeah, okay. So we want to use, we're going to define some additional information because our project's not incredibly simplistic. We're going to define the Scala version that we want to use, and we're going to define it as 2.12.4, which is the latest version of Scala. And then we can stop there. That's our basic project layout. But we need to define our project directory and then our plugins.sbt, because we need to pull in the Scala.js SBT plugin. So I'm going to go in and I'm going to say add SBT plugin. Now, just to tell you, I do have a cheat sheet here because I don't remember a lot of this off the top of my head, and I'm glad I made it because, well, I don't have my laptop. So All right, so this is what this does is it adds like a Maven dependency would be. The organization is org.scala.js, and then our artifact name is sbt-scala.js, and then our version is 0.6.21, which is the latest version. Now, we're adding in our plugins so that we can say add an SBT plugin so it's accessible to us in our build.sbt file. That's all it's required to actually add that plugin, but now we need to actually modify our build.sbt file so that we can actually tell it that this thing uses it. So it's weird, it puts the line numbers in reverse. The line numbers are in reverse.
Relative.
Do what?
Relative.
Oh, it's relative to where you, oh, that's weird. Strange, okay. So, moving on. Yes, complicated, isn't it? Enable plugins, Scala.js plugin. That's it. That's all we have to do to make this a Scala.js project. Now, we do want to add a couple other things because unfortunately, Scala.js is in sort of a migration mode. They're moving from 0.6x to 1.0, and so we have to, there's all this compliance stuff that they're doing now, so I have to add a couple of additional things. Scala.js use main module initializer. This feels more like Maven, doesn't it? So this is just telling the Scala.js compiler that I want to use standard main methods, like I would use in any main args static companion object. And then I also want to define Scala C options plus equals. Yeah, it'd be really cool if I knew this all off the top of my head, wouldn't it? SJS. This is specifically compliance here because in older versions of Scala.js, you had to do this JS defined annotation on anything that's actually utilized in Scala, in JavaScript. That's a JavaScript object that you're utilizing, and this turns it on by default, so you don't have to use the annotation anymore. This is going to go away in Scala.js 1.0, but in this weird stage that we're in, we are stuck with it. All right, so let's see, make directory p source main Scala hello, right? Okay. I'm going to make a mighty blunder soon, I'm sure. Where'd the package hello come from? What voodoo do you have going on in your vim? That's just wacky. Okay. Oh, that's not what I meant to do. Go back. Okay. Boom. All right. Anybody that's ever used Scala before, this looks like Scala, not Scala.js, right? So I just got my main method like I would for any Scala code. And yeah, and for you Java guys, this would be a whole lot more public, static, void, main, string, args stuff. But this is essentially the equivalent. So what we're going to do now is we're going to hopefully see if SBT is installed. It is, isn't it? Sweet. Good. Yeah. Yeah, we got to download stuff that he's never used before. So it's pulling in some of the dependencies for SBT.
I have a question.
Yeah.
I saw that there's some types there, like there's an array being used, a string type being used. If that's compiling down into JavaScript, is it going to use the JavaScript equivalent
Yes.
of the array?
Yes, for the most part it does. Sometimes it does. It defines its own object structures as well, because some things are more complicated than what JavaScript allows in their native implementations. So nice. Okay, so I can say compile, and we'll see if my code actually compiles here. And it's going to download more dependencies. I guess I can't complain too much about Apple since this one actually works. Mine doesn't. Okay, compiles, sweet. All right, so code compiles, but we don't have JavaScript yet. We just have compiled Scala code. So what we use now is, it's called fastopt.js. It's a command that compiles our Scala code down to a JavaScript file. Now, there are two commands here. There's fastopt.js and there's fullopt.js. Fastopt.js, we can, okay. Oh, capital S, case sensitivity. All right, that took 2 seconds. Now, just for kicks, we're going to run fullopt.js. 2 seconds. Never mind. All right, for the most part, fullopt.js takes a lot longer to run than fastopt. But because we've got such a crazy simple class here, it takes the same amount of time, making me look like the fool. But that's okay. As you'll see, whenever you do production releases, you're going to want to use fullopt.js because it makes the size significantly smaller. And we have a problem. No, we don't. We're okay. Okay. All right. So I need to create. So we're gonna look at our target directory, Scala. What do we got here? So now we've got a fastopt and a fullopt.js file. So you can see here we've got the fastopt that's 87K for hello world. I know that seems kind of crazy, right? But it has to include parts of the Scala library into it. But as you get larger projects, you'll see that that doesn't exponentially grow in contrast. So don't worry about that as much. But you can see the fullopt.js is actually 11K. So substantially smaller. And it's supposed to take longer to do that, but anyway, so deploying to production, fullopt.js, substantially smaller downloads. For development, you get greater speed with fastopt, hence the name fastopt. And you can really quickly update it so you can do testing and stuff whenever you're running your examples. All right, so now we have Scala.js. No, I can't do that. Actually, yeah. Now we need to create an HTML file to run this because JavaScript's cool and everything, but it kind of doesn't exist in the browser without HTML. So we need an HTML file to actually run this. And target Scala. I miss IntelliJ. Okay, pretty simple, right? All we're doing is we're creating an empty HTML file that defines our script source to point to our fastopt.js file. So I think this will work without running a server, but that is one of the cool things about IntelliJ. IntelliJ runs a web server for you as soon as you try to load one, but we'll see. If not, I'm blaming him. Okay, let's stop it. How do I open a file? Do what? Oh. You're going to make me look the fool, aren't you? Yeah, I don't know the command. Chrome? Oh. Well, that's ridiculously simple. Wow. And now let's open up our console tools. And if everything worked, hello world, right? Sweet. Yeah. All right, so let's do something more than that, because that's pretty crappy. All right, so now let's go back into our source, main, Scala, hello. Now let's do some, oh, actually, we need dependencies. So now we want to add a library dependency for the Scala.js DOM. There's a library for that we can use. And it will allow us to access things like document, body, window, HTML elements, all that good crap. So now we're going to just say library dependencies plus equals org.scala.js. That's our organization. Scala.js DOM 0.9.1. All right, so Maven people, this is very similar. I mean, you just got your organization, your artifact ID, and your version. But notice here, for any of you Scala people, there's 3 % signs instead of 2. And so in SBT, you define 1% sign for like a Java dependency. You use 2% signs, and it will automatically append the Scala version number to your artifact because you can cross-build to multiple versions of Scala. So for instance, in this case, it would append Scala.js-DOM underscore 2.12 because we're using 2.12. And if we did cross-compiling, it would do 2.12 and 2.11 or 2.13, whatever we're using. So with the 3% signs, what it does is it allows us to do cross-compiling for Scala.js and non-Scala.js implementations. But in this case, we're only in the Scala.js environment. We'll talk about cross-building code here in a bit if we have time. All right, so let's go faster. All right, so now we're gonna edit our hello world, and we're gonna get, it's so weird. The keyboard shortcuts on Vim are different than what I use. All right, so now what we want to do is we're going to import org.scala.js.dom.star. So what that gives us is access to the Scala.js DOM from that library dependency we just brought in. So now what we want to do is we're going to get a handle on our body. That sounds dirty. Okay. We're going to get a reference to that, and then we're going to create a new H1. And then we are going to set content to that. HTML equals hello world. And then we're going to say body.append child H1. This looks pretty familiar, doesn't it, you JavaScript guys? Like really familiar? Because this is exactly what you, almost, well, not the val, but you'd use var, but almost exactly what you'd use in JavaScript. And that's on purpose. I mean, this is a Scala DSL for working with JavaScript code, JavaScript-like code, and interacting with the browser. So you do have access to all that good stuff. Now, we can also do other things. Unfortunately, because this is a direct mapping, well, let's take a look at it. We'll come back to it in a second. All right, so now we're going to say SBT clean fast opt JS. All right. It recompiled now. Now let's see if we can see anything on our screen. Hello world, nice. So now, you don't have to clap every time. All right, so now we've got interaction with the browser directly instead of just monkeying with the console. So let's look at our elements here. And you can see here there is indeed an H1 element that has an inner HTML just like we told it to. So pretty straightforward stuff. All right, so now let's go back to, all right, so we'll quickly go over this stuff again. A lot of this stuff is things I've already explained, but our SBT file, we've got our name for the project that would be the dependency if we, would be the artifact name, for example. We enabled the plugins for the Scala.js plugin. We enabled these last two aren't actually required. You can get away without using them at all in Scala.js, but they just make it a little bit cleaner to work with, and it's preferred by default now, at least. And those should be defaulted to on as soon as Scala.js 1.0 is released. And then we added our SBT plugin reference from the plugins.sbt. We created our hello world example. We did our project setup to add the Scala.js DOM, which gave us access to the document object model for the browser. And then we created our element, and we did more here. So let's go back here real quick. And so what's cool here is this is just an HTML element as far as it's concerned, because type information is lost in the JavaScript realm. And so, and in fact, it doesn't know, because we're passing in a string for what element to create to model what happens in JavaScript. In fact, it calls exactly what happens in JavaScript. We don't know that this is in fact an H1. So what I can do, and please forgive me for this, instance of, I can do that, and now it's an H1 element, and then all the type information related to an H1 is there. Now, for H1, it doesn't really make much difference because you're not doing much specific to H1 element, but if you had like an HTML input field or a form field or an anchor or anything like that, it gives you all that type information, and so you can set the source, you can set the target, you can do all that stuff directly on it with pure type safety. So that's a very nice aspect of it, and there are wrappers around these in other facades that exist, and other libraries exist for Scala.js to make it a little bit nicer, so you're not doing casting calls whenever you're making elements and such. But the JavaScript library, or the Scala.js library dependency that we pulled in is meant to be a straight, direct one-to-one relational mapping between the two. So, okay. Any questions before I move on? Okay, moving. All right, size matters. Now, we already talked about fast opt versus full opt. Size difference is pretty big. Now, I'm sure that you'll realize that if I just created a straight JS file, it would be like 1K versus the 11K that the full opt was. That's fairly substantial, but you know, we live in an age of fast internet connections, so get over it. There is a payoff. There is a price you pay for this, but it's worth it because you do get so much with Scala that just makes life a lot easier. JS deps. Okay, so what we pulled in there did not have any specific JavaScript dependencies, but there is something that gets generated for you. Let's go back into our target and look real quick. Sorry, I'm trying to go as fast as I can because I know we're going to run out of time quickly. So notice here, it didn't create one. Okay. Oh, no, it did. Okay, I just can't read. You see how we've got here this hello Scala.js JS deps file that's empty? Well, what happens there is if you've got any dependencies in your project or you have any local dependencies to JavaScript files, it will merge them in and basically create a minified, compressed version of all of your JavaScript file dependencies in that. And so you'd add an additional source entry right above your inclusion of the fast opt to include the JS deps, which would pull in any JavaScript specific code. So like if you wanted to rely on jQuery, it would pull in the jQuery library as a dependency there. It would inject that in, minify it, and create a map file for it, and then you'd be able to utilize it there. And then you just work like it exists, and it takes care of loading it all and doing all that stuff for you. Make sense? Okay. So that's what JS Steps is, and it becomes very helpful whenever you're writing facades around existing JavaScript libraries, because there's a lot of that you have to do unless you want to reinvent the world, because there's a lot of really cool JavaScript libraries out there that haven't switched to Scala.js yet for some reason. Okay, so cross projects. Like I said earlier, you can cross-build your code for the JVM and for Scala.js. So this is an example of an application in SBT. It's a multi-project build that defines 2 sub-projects as part of your shared project. So what happens here in the file system, it's really freaking me out. You have your app directory, and then within that you have 3 directories that get created, a shared directory, a JS directory, and a JVM directory. Now, as you might expect, the shared directory gets code that's shared between both of them. So you can create common elements, common structures and things that you want accessible on the client and on the server, which becomes very, very useful if you're doing like AJAX calls and you want to do JSON communication back and forth with objects. You can do so and then just pass those objects back and forth. You serialize, you deserialize on the other side, the exact same object. It's very nice. And then you have, you can do JS dependencies, you can do JVM dependencies, all of those, and you can manage your JVM settings, JS settings, all within this as well. So there is the cross-project system library that exists for this was originally written just for Scala.js, but now it's been ported so it's more of a general use project, and now it has support for JVM, JS, and native. So Scala native has co-opted it as well, so that you can write code that you can then target to both the JVM, the JavaScript environment, which does, by the way, just a real quick side note, you can also compile for Node.js without any trouble. Also, it's got there's lots of facades and lots of libraries for working with Node.js, and then you can also compile native. Scala native is a much younger system and out of the scope of this discussion for the most part, but it allows you to write Scala code and then compile it to a native runnable application that does not need a runtime environment whatsoever. But then let's see here, JavaScript facades. This is a quick example of a facade that wraps an existing JavaScript object. You can see here we've got our JS.native telling the compiler that this is a native class that already exists, and we're just representing it as a facade to the JavaScript source code that we say is somewhere out there, and it'll be accessible at runtime. And then we define an annotation called JS global, which we don't necessarily have to define. In fact, I wouldn't have to define it here at all, because the package, as long as the package matches, it will just work. But for example usage here, JS global, we can define our package and global name as far as what it's represented as in the JavaScript world. So we can define our package structure differently, and even our class names differently in the Scala code, and then when we compile it to JavaScript, it actually represents it in the JavaScript differently to map. And so we can see here, we're just defining a class that extends JS object, which extending JS object is absolutely required if you're going to do that, which doesn't especially mean anything except for the compiler, but it adds some additional methods and things specific to JavaScript. And then we define 4 methods here that we don't know what the body of them is, because they're, like we said, they're defined in JavaScript. So we say JS native, and at the compile time, it basically just says, okay, since this object is actually invoking JavaScript code, it just invokes those JavaScript methods on that object. And so I can instantiate a bounding box now inside of my Scala code, and it uses OpenType's bounding box, the implementation that's in the JavaScript, to do all that. And whenever I invoke any methods or any variables or anything like that, it calls off to JavaScript. It creates a very clean mapping between Scala and JavaScript. Any questions about that? Because that's that's one of the most confusing things about this is how Scala and JavaScript connect. Okay. Okay, so I'm about done. Any questions in general? Anything else you want me to cover? Yeah.
Is there like facade support if you wanted to do something on top of the like Angular or React?
Yes, there already is, in fact. Actually, here's a open. There are 18 different facades related to Angular. So, yeah, so you can see there's quite a few here, but there's a ton of facades that already exist out there. And even if you need to create one yourself, it's pretty trivial to do so, as we've seen. I mean, it takes a little bit of getting used to, understanding the structure and everything. And if it's been a while since I've written one, I often will pull up another one just so I can remember how I'm supposed to do this. But it's not that difficult. Creating facades is actually pretty trivial, and lots of people do it. Yes, you in the back.
Is it also, I think there are some projects like Scala HTML and Scala CSS.
Mm-hmm.
Is that part of the same ecosystem, or those like
Yeah.
completely?
Yeah, for the most part, they are either facades or they're libraries. A facade wraps around existing JavaScript libraries by definition, because it's a facade around something that already exists, whereas you have just Scala.js libraries that are just libraries that were written from scratch that are meant to be used to interact with in the JavaScript realm.
Are you using this at work?
Yes. Actually, I'm technically not at the moment, but I do a lot on the side. I've written a UI framework, in fact, that builds a lot on top of Scala.js.
When you set up a build pipeline for this, how does this Scala compiling get put into your server and then served?
That's a really good question. You can use cross-project in Scala.js, but as stated multiple times by the creator of that, that's not what it's meant for. I actually have a plugin that I wrote that does that for you, and it manages cross-project, because most of the time, as a Scala developer, I'm dealing client and server. I don't usually write things that are just client-side, because it's great to do as much heavy lifting as you can in the browser and make the user do the work. User's machine waste the CPU cycles instead of my server, but at the end of the day, almost everything I do has to contact the server to do something. So most of my work has to do with that interaction between the client and the server. So in my UI project, and there's a couple of other projects that do similar things, it facilitates that, and it basically injects the generated source into the JVM server instance in the resources directory so that it's accessible.
Is the event support pretty good for Scala.js?
You mean for JavaScript events?
Yeah.
Dealing with DOM? Yeah, it's exactly the same as it is in JavaScript, because you can just add window.add event listener, and then you say click or whatever, and then you add a function. And you can do function conversions between JS functions and Scala functions. So it's pretty clean there.
How crazy can you go on the Scala side? Like, can you like bring in like Scala Z or Facades?
Most of them you can now, because most of them cross-compile, but they do have to be cross-compiled for it. Some of them don't work with Scala.js just because most of them, the reasons that libraries don't right now is because they have specific dependencies on things that aren't accessible in Scala.js. Like they access the file system, or they do something with the environment variables, or something crazy that you just can't do in the browser. Yeah. Let's see. I think we're about done. So I posted a link to this mostly because I needed a link to it, but I posted on the meetup, so if you want a copy of this, you are welcome to grab it. Mostly just for this, because I mean the presentation is pretty bland because I spend most of my time looking at code. But these references are pretty good. The Scala.js site is a very useful thing. Scala Fiddle, really awesome because you can write Scala.js code and you can compile it there and see it run in the browser. So, well, it actually compiles on the server and then sends it back, but it's fast, so it doesn't matter. Then the DOM facade that we were talking about is the Scala.js DOM, that's referenced there. And then Gitter channel for Scala.js, very, very, very active. And then definitely Scala link that I had open just a minute ago, that's the last thing there. And then some final thoughts that we don't need to worry about. Then that's me, and we're done. All right, any other questions? 3 minutes early.